Hello, Matt here from chemistrystudent.com. In this video, we're going to look at a hard example for balancing equations, the reaction between sulfur and nitric acid. We're going to go through a step-by-step method for how to balance it. Now, I have to say there are lots of different methods you can use to balance these kind of equations. This is just how I approach and teach these kind of examples with my students. In the reaction, sulfur reacts with nitric acid to form sulfuric acid, nitrogen dioxide and water. S plus HNO3 to H2SO4 plus NO2 plus H2O. This is quite tricky as oxygen is present in all the products formed. When tackling this, the first thing I would recommend is to ignore the sulfur. The sulfur on the left is by itself, meaning it's easy to balance at the end, once the H2SO4 has been dealt with. Next, try and look for an element in a reactant that is only in one of the products. Here, for example, both the nitric acid, HNO3, and nitrogen dioxide, NO2, contain nitrogen. Nothing else does. The ratio of HNO3 to NO2 must be 1:1 then, as they both contain one nitrogen atom. This means as we change HNO3 when we balance, we must change NO2 at the same time. Let's write that as X for HNO3 and this would give X NO2. This will help remind us about this later on. Now, there are 3 lots of oxygen in each HNO3, and if for each HNO3 we are making one NO2 as well, that leaves 1 oxygen left over each time. Well, H2SO4 has 4 lots of oxygen in, meaning to make one H2SO4 we would need 4 HNO3s. As remember, each HNO3 must also make an NO2. Based on this then, that would give S plus 4HNO3 to H2SO4 plus 4NO2 plus H2O. Before we go any further, it's a good idea to see how we are balanced at the moment. On the left, 1 times S, 4 times H, 4 times N, and 12 times O. On the right, 4 times H, 2 from H2SO4, 2 from H2O, 1 times S, 13 times O, 4 from H2SO4, 8 from HNO2, and 1 from H2O, and 4 times N. Starting to look good. It is the oxygens we need to address next. We've just balanced up the HNO3 to H2SO4 and NO2, meaning it is the H2O we need to consider now. 13 times O on the right and 12 times O on the left means we need another O on the left. This can only be done by adding another HNO3. This would take us to 5 HNO3, which, without going any further, we can know this won't be correct, as the number of hydrogens on the right in total must be an even number, as there are 2 in H2SO4 and 2 in H2O, always given an even number overall. And an odd number of HNO3 would have to mean an odd number of hydrogens on the right-hand side. So we need to go to 6 HNO3 before we can even think about trying to rebalance the equation. We know that 6 HNO3 would have to give 6 NO2 as well, as remember we've already said the ratio of HNO3 to NO2 is 1:1. Remember the X earlier on. And we don't want to touch the H2SO4 again right now. This would give then S plus 6 HNO3 to H2SO4 plus 6 NO2 plus H2O. On the left, 1 times S, 6 times H, 6 times N, 18 times O. On the right, 1 times S, 4 times H from H2SO4 and H2O, 6 times N, 17 times O. The sulfurs cancel, the nitrogens cancel, and 4 of the hydrogens and 17 of the oxygens cancel, leaving 2H and 1 O short on the right-hand side. This can simply be addressed by forming 2H2O instead of 1H2O. Now giving S plus 6HNO3 to H2SO4 plus 6NO2 plus 2H2O. Whew! Phew, we've balanced it. Now remember, there is always more than one way to balance an equation. This is just the method and the way I would approach this. It may have seemed a bit confusing in the middle there, but if you understand how to balance these equations, it really gives you a powerful tool in more complicated and challenging exam-based questions. I hope you found this video useful. Please check out other relevant videos in the links given in the description below and visit chemistrystudent.com for free notes and revision materials.